Hello children, welcome to channel Sube. Children, today I am going to discuss question number 4 from the MCQ part of 2022-23 Physics New Syllabus paper. A stationary magnetic field does not interact with any first one, stationary electric charge. Second, moving electric charges. Third one, current carrying wire. Fourth one, stationary permanent magnets. 5, moving permanent magnets. So children, first of all let us discuss what is this stationary magnetic field. We can create a stationary magnetic field by using there are two methods. The first one, the easiest one is we can use just bar magnets. You must have seen like this. So those are permanent magnets. So they have marked N and S. Even though it is not there, the marks are not there, you can find it by hanging it using a thread at the center, fixed thread at the center. When you balance it using that thread, the magnet turns to the north pole of the earth. So that end is called the north pole of this magnet, so that you can find out it if it is not marked on the magnet. It is not necessary here. If you have a magnet, permanent magnet like this, so there is a stationary, stable field, magnetic field. So like this, there is a magnetic field. It doesn't change. That is the idea. If we say stationary, it is fixed. Fixed means the field intensity B, the flux intensity or field intensity we can say, or flux density we can say, that is permanent. It is not changing. So that is one way. The another way is to use a coil. Use a coil like this. And the two ends of the wire we can connect to a battery. Give a steady DC. It must be DC, direct current, not AC. If we gave AC, what happens? The current changes with the time, and also the flux density, the flux or the field intensity change means it is not stable. It is not then stationary. The B is fixed here when you use a DC source. So we can generate a stationary magnetic field using one of these methods. Then what they say, the first one, no, not the first one, let us take this fourth one and fifth one first, because those are easier. Stationary permanent magnets, we are talking about this one, stationary permanent magnet. So if we place the stationary permanent magnet closer to this previous magnet, say south pole and north pole like this, so what happens? There will be a interaction, that means a motion. The force is acting on this second one, and also both have forces. So it is an attraction or repel. So repulsion or attraction over repulsion. So we can see the motion it must move this way or that way, out of the magnet or towards the magnet. So that is a interaction. So what they ask is not interact. What is the incident? That is we can say not interaction. There is no interaction. So here there is an interaction because it is moved towards, so out of this first magnet. So this one therefore is not the correct answer. Stationary magnets always attract each other. Therefore we can say that this one is wrong, because what they ask is not interacted. So it is interacted here. Then moving permanent magnets. Even though the magnet is stationary, the second one, or moving, always it is attracted by this the first magnet, the fixed one. We imagine that this one is fixed. So the second one, whether it is moving or not, doesn't matter, it is attracted towards this first magnet. So therefore this one will not the answer. Moving permanent magnets also attracted. So then current carrying wire. So let us discuss this one now. Current carrying wire. So the same thing happens. I am talking about this previous the fourth one and fifth one. If we place the magnet here, a permanent magnet, the same thing happens. Therefore I don't discuss it with this one. The same thing happens because this one is a permanent stationary field, because we have supplied DC current. So they say same thing happen here also. Current carrying wire. Current carrying wire. If we place the current carrying wire perpendicular to this, if the current is I, if the length is L, we know there will be a force F equals BIL. We know this equation even. So since there is a current, there must be a force. If the B is perpendicular to the current. So if the wire, current carrying wire, we have placed parallel like this, so the magnetic field is circular like this here. So if we place the wire like this parallel, so then there will be no force actually, even though there is a current and there is a field intensity B, but since they are parallel to each other, there will be no force. But this instant it is very difficult to get this instant because the most probability is there to not to perpendicular. This perpendicular situation is very difficult to achieve because we don't see this flux lines, and also it is very difficult to place this wire parallel to the flux line. So therefore the probability is not perpendicular, not parallel. So therefore there must be a force always. There must be a force always. That is the most probable thing. So therefore there is a force. That means there is an interaction. So what they ask is not interact. So therefore this one is not the answer, because there is a interaction always. Because this parallel condition is very difficult to be achieved. So this one is wrong, therefore, current carrying wires. So now let us discuss this one, the second one, moving electric charges. So if there is a charge, say Q, so it is moving, so it has a velocity. Moving means it has a velocity. So we know there is a equation F equals B Q V. So if there is a velocity, that means a motion, there must be a force. So therefore if there is a force, that means the interaction. So what they ask is not interacted. So this one is wrong. Therefore, there is a interaction if the charged particle is moving, but actually if it is moving parallel to this flux intensity, flux line parallel like this, so there will be no force, but that situation is very difficult to achieve. Most probably we place this, most probably this velocity is not parallel to the flux direction of the flux density. So therefore if we place a motion charge that is moving, so there will be a force, there will be a force. So this one therefore wrong. Moving electric charge always has a force. So you must have learned in chemistry. In chemistry there is a practical, we say Crookes tube. You must have done that, Crookes tube. So using Crookes tubes is something like this. There are two cathode and anode, there are two metal terminals here. This one is something like this, I think. So somehow if we connected this to a high voltage about 10,000 volts, so there is an instrument, you know, in the laboratory, sparking device like this. So when you connect it to the main supply, what happens? There is a spark here, so we can adjust it. There are knobs, so there is a spark. So we connect this to this Crookes tube. In chemistry I have seen, that's why I am explaining. So then as soon as you put on the switch, what happens? You can see the charges moving like this, but you don't see these charges. What you see is light, a sort of illumination, because there is a zinc sulfide plated metal plate here by the side of the inside of this tube. So when these particles strike on this zinc sulfide plate, what happens? They illuminate. The path get illuminated, so we can see the path of these charges. So first it is like this, straight lines. So they place then a magnet like this by the side, a magnet, permanent magnet. So then what happens? These charges change their direction of motion like this, bent. So that means there is an interaction. So definitely there is an interaction. If you have done that practical, no problem, you understand that moving electric charges have a interaction by the magnets. So that is what they show using this experiment. So it is clear now. So that is finished. Now we can go to this first one, stationary electric charges. So if the electric charge is stationary, that means there is no velocity. So if this V is equal 0, then F must be 0. So that means there is no interaction. So therefore this one is correct. What they ask is does not interact. If there is no interaction, so that is the correct answer. So this one is therefore correct. To have a force, there must be a velocity. If there is no velocity, that means stationary electric charge. It is a stationary electric charge if it has no velocity. So there is no force as well. So therefore it is correct. So children, I think you can understand this. It is so. So children, I think you are happy because I explained everything. I explained even what is this stationary magnetic field even. So I think you are happy. So I explained this Crookes tubes and also and there are two methods I explained. DC, you must supply DC to this one. If you supply AC, it will not work because the B change. this B then changes. If you used AC current, what happens? The B changes like this. B changes like this, positive, negative, like that. So this way, like that it changes. Therefore, then it is not valid for this question. What they say is stationary magnetic field. So it can't change like that. So children, I think you are happy. If you are happy, you know what you have to do. You have to make me happy too by subscribing my channel. Only if you haven't still subscribed it. Don't subscribe twice, then it will be cancelled. So if you haven't yet subscribed my channel, please subscribe it and press the bell icon, and also share my link among your friends, and also give me a thumb up, a like. Then children, thank you very much for watching my videos, and thank you very much for those who already have subscribed to my channel. See you tomorrow at 6 o'clock in the evening. Goodbye.